The touchscreen, a display that's sensitive to human touch or a stylus, has been around for nearly half a century. It's used in ATM machines, tablets, computers, phones, and continues to appear in newer technologies. Have you ever wondered what goes behind this convenient piece of technology? There are many types of touchscreens. The two most commonly used are the resistive and the capacitive touchscreen. Resistive touchscreens were founded by Samuel J. Hurst in 1971. The resistive touchscreens are the most common type of touchscreens. It is mainly made up of two thin layers separated by a thin gap with spacer dot. These two layers are coated with transparent material, indium tin oxide, or the ITO on one side, with the coated sides facing each other inside the gap, just like two pieces of bread in a sandwich. The top and bottom sheets have uniform resistance value over its surface. As the top layer gets pressed, it makes contact with the bottom layer. Upon contact, electricity gets conducted at that point. This stimulus is transferred to the adjacent layer that registers in the system as coordinates, enabling the sensing of touch. Spacer dots are usually printed on the bottom sheets to prevent the top and bottom sheets from contacting when not pressed. Size and placement of the dot spacers affect the operational feeling. The downside of resistive touchscreens is that it cannot detect another touch when a stylus is already touching it. It does not allow multi-touch gestures. Because of the limitations of the resistive touchscreen comes the idea of the other type, the capacitive touchscreen. But did you know that your body has electrical properties? Contrary to the resistive touchscreen, the capacitive touchscreen makes use of this to work. A capacitive screen is usually made of one insulating layer, such as glass, which is coated by a transparent conductive material on the inside. Since the human body is conductive, which means electricity can pass through it, you cause a change in the screen's electrical field when you touch the screen with your finger. This change is registered, and the location of the touch is determined by a processor. The reason you cannot use a capacitive screen while wearing gloves is because the gloves are not conductive, and the touch does not cause any change in the electrostatic field. Same goes for non-capacitive styluses. Since capacitive screens are made of one main layer, which is constantly getting thinner as technology advances, these screens are not only more sensitive and accurate, the display itself can be much sharper. And of course, capacitive touchscreens can also make use of multi-touch gestures, but only by using several fingers at the same time. Simple, right?